All right, hello, ladies and gentlemen. Back again for a little bit more. All right, today's lesson is lesson 1.4. Hopefully you guys are doing okay without me. I apologize. All right, so the first thing, again, is a little bit of vocabulary, but I'm also going to add some notation. So an angle is two different rays that have the same initial point. All right, so if you have to write a definition, initial point, what does that mean? So let's just say this is my initial point, A, and then I have a ray. Let's do this is B, and then boop, that's C. Boom, look at that. It's an angle. What? That's so crazy. Hey, just so you know, there are different ways to name an angle. And when you name an angle, really order does matter. You could just use the initial point with the notation of an angle, angle A. You could also say this is angle BAC or angle CAB. It's really important when you name them with the three letters that you're able to trace the angle with your finger, like go in order. Okay, so I would never say CBA because C doesn't connect to B at any point in this angle. Okay, notation is super important. I know you guys are struggling a little bit with that on Friday, so please make sure, if anything, if you don't write the definitions, you at least write the notation. All right, the sides of an angle are made up of rays. Duh, we just talked about that. So the sides of that angle are, I don't know why I just did that dot. All right, AB, remember, there's my ray, and AC. My two rays, where A is the initial point, obviously the intersection of the two rays that have to share the same line. The vertex of an angle is the initial point. So the vertex in this case is point A. Boom. Nailed it. Again, I'll repeat myself. If I go too fast, just make sure that you pause the video so you can get all this information because it's important. All right, moving on. Congruent angles are angles that have the same measure. That's kind of crazy. Of course, we remember the congruency notation is the equal sign with a little swoopy, I like to call it. So we could say angle A is congruent to angle B. Boom. Nice, huh? That looks good. All right, moving on. Number 5. I'm sorry the numbers got cut off. I don't know what happened. Acute angle measures greater than 0 but less than 90. It's cute, it's tiny, it's beautiful. A right angle measures exactly 90. And remember with the right angle, we always see that notation with the little, whoop. When you see that little box in the corner, I guess you can call it a corner. That's notating that's 90 degrees. It's like goes without saying. Like everybody knows. Because you call that a postulate. All right, obtuse measures greater than 90 but less than 180. I guess I could draw you some samples here. So here's a little acute angle. You can clearly see it's less than 90. Here's an obtuse angle. It's obviously bigger than 90. And then we have a straight angle. So weird. It measures exactly 80 degrees. What does a straight angle look like? It looks like a line. That's just weird. But I mean, nobody calls it a straight angle, so I don't even know why it's on there, but whatever, now we know. Straight angle. All right, an angle bisector. All right, you've heard the term bisector before. I talked about it. Hopefully you know what that means. Because you think about a bicycle has two wheels. A bisector splits the angle into equal parts. So let's draw an angle bisector. Let's first off let's just say this angle measure is about 40 degrees. All right? And I'm going to draw an angle bisector. Excuse me, I'm so sorry. All right? So that little angle bisector, let's just say this is A, and this is F. That angle bisector just bisected that 40 degrees. So on either side here, this is going to be 20 degrees. This is also going to be 20 degrees. Angle bisector bisects the angle, splits it directly down the center. All right, now we have our protractor postulate. Consider a point A on one side of OB. All right, and this information isn't on your notes, so you don't have to copy it down if you don't want to. The ray formed by OA can be matched 1-to-1 with the real numbers from 0 degrees to 180, meaning if you would pretend like this line would flatten down here, that would be 0 degrees. Let's say it expands all the way over here, that would be 180. Great. Usually I have you guys, we measure this one together, but we're not going to. There's a couple examples below that I want you to get your protractors out. I'm going to do my best because I have this tool here, but it doesn't work like a protractor does. Hopefully you guys remember, I put protractors on the desk. They're in a little white, clear Tupperware container, I guess you want to call it, with the gray lid. There's rulers and protractors in there. Please just make sure you put them back when you're finished. All right, let's check it out. Let's see. First off, let me move this over because I think it looks like that. You can't see what's going on. All right, I'm going to get my tool, my math tool, and my protractor. Okay, so bear with me. I'm not the best with this piece of town. All right, so the thing about a protractor is, do you see this part right here? You want that to line up with this vertex right there. Okay, and you want this to like line up exactly with one of your rays of your angle. So I'm going to do my very best. Come on, you. I'm going to try to get this on the corner there. Come on. Oh my gosh. You see what I'm saying? Like I just have major difficulties with this thing. Okay, and notice on the protractor there's two sets of numbers. There's small and large. That depends if the angle's obtuse or acute. And which direction it's facing. Like this angle's open here, but the angle below it's open the other way. So obviously if you look at that angle I'm on with the protractor, it's obtuse. So we're going to use the big numbers. So I'm going to say it's about 144 degrees. You still okay about that? All right, cool. Here, I'm going to try to drag it over again and do this one. All right, so I make sure that my little crosshairs are lined up with my vertex. That's kind of good. Now, somehow I'm supposed to, come on, I got to get my initial, I got it, oh, you little bugger. There we go, lining it up with the 0, with one of the rays. Boom, oh my gosh, I feel so happy about that. Like, to me, that looks like it's dead set at 50. If you got 51, close enough, you know what I mean? 50 degrees. That's lovely. All right. Then we're going to take our protractor. Actually, I'm not because it's driving me crazy. You guys, I do want you to practice with your protractor, so you should be able to get the same measurements that I have. I think I have about 15 degrees. Oh, let's just take it over here. All right, we're going to line this up with my vertex as best I can. And now I got to try to figure out how to get this in. Like sometimes oh, there it is. Oh, there it goes. See how this angle's facing the other way? And we're going to use the small numbers again because it's an acute angle. So, yeah, 16 degrees about. Okay. Oh, look at this bad boy. I'm like, hey, it's 90. Let's not mess around. But let's just come on with me. All right, we're bringing this bad boy over here. Line up that little crosshairs with the vertex. Now I gotta get this set. Crazy town. Guys, you think if you're having struggles, this struggle is legit. So yeah, I was right. I assumed this was 90 degrees, and I was on the money. Look at this guy down here at the bottom. That's a straight angle. We just talked about that. What do you think that is? It's 180. Fabulous. I mean, I could take my little fancy protractor if I could grab it and bring it down. Boom, 180. Only I don't know where the vertex is on that angle, but anyway, I just have to put this up because that's just how I do, because I'm a weirdo. All right, so hopefully you were able to practice a little bit with your protractor and you are good. All right, we're going to talk about another postulate, right? A rule without proof. It's good to go. The angle addition postulate, very similar to the segment addition. We're pretty much going to add them together. So I'm going to just throw some numbers in here. I don't think you guys, first off, you need to copy down that angle, right? So what I did is I would start with this ray, right, SR, then ST, and then draw this little segment. Not necessarily a segment bisector, but a ray coming out of the vertex, not segment. Sorry about that. All right, so I'm going to throw in some numbers here. Let's say the measure of this angle is 30 degrees, and the measure of this angle is 20 degrees. Well, if RSP is 30, RSP is 30, plus PST is 20, the measure of the large angle is 50. Boom, 50 degrees. That is so nice. And now my protractor's still there, but that's okay because it's fine. Yeah. All right, so now we're going to find the given measures using angle addition postulate. And I'm sorry if they're static. I don't know how to fix it. It's literally like 7:30 at night, and I'm still here trying to make this video for you guys. Anyway, so given the measure, okay, first off, I want to just let you know that this little m means measure. All right, the measure. That's how my geometry teacher in college used to always say measure. She's so weird. I guess I'm going to do it anyway. And this guy, we already know, is the notation for angle. So the measure of the angle LKN is 145. So LKN. So that's the big boy, right? The whole thing is 145 degrees. We're going to find the little angles included, right? So LKM is 2x plus 10, and MKN is 4x minus 3. And we know that the whole thing is 145. We just have an equation now. You can solve this, right? Always combine like terms on the same side first. 2 and 4, that gives me 6x. 10 and negative 3, that gives me 7, equals 145. All right, we got a two-step. Subtract 7. 6x equals 138. Divide by 6, and I get x equals 23. And you're like, hey, hooray! I know the answer. But really, I need to know the measure of the angle. So just like we did before with the segment addition, we're going to do now with the angle addition is plug it in. So 2 times 23 plus 10, what's that give us? Let's see, what does that give us? 56. All right, and then we do 4 times 23 minus 3. We could also, remember, you can also take 145. You could take the whole thing, subtract what you got already, and find it that way too. All right, let's see if we get the same number. So 4 times 23 minus 3, that gives me 89. 145 minus 56 is also 89. So there is one way to go about it. I'm sorry, more than one way. All right. Hopefully you're doing okay. We just have one more example, and then you're finished for today, my little darlings. So let us move on. Oh, I hate it when the words are off the screen. That makes me sad. Whoa, that's crazy town. All right, so we know it says find the value of x when the ray BD bisects angle ABC. Okay, remember that ray splits it in half because it's bisecting. Bisect, split in 2 equal parts. I cannot emphasize that enough. All right, okay. So now how are we going to set up an equation if we don't know the measure of the whole thing? Well, we know that this ray bisects the angle. So that means ABD is the same measure as CBD. Correct? Correct. So 6x plus 15 is equal to 10x minus 25. You know, whenever you get stuff on both sides, I always like to move my letters to the left. I told you that. You do what you got to do. Just make sure you don't mess it up. Don't move everything to one side. Then your little scale is going to be all messed up. So minus 10x. That gives me negative 4x plus 15 equals negative 25. Subtract 15. Negative 4x is equal to negative 40. I feel like if I change my voice, you guys will get excited. Are you excited? I hope so. All right, divide both sides by -4 and x equals 10. Yay! That's so awesome. Okay, we have half an answer here. What do we got to do with x? I know what you're saying. You're all like, plug it in. And I'm like, yes, you're so good at this. Okay, 6 times 10 is 60, plus 15 is 75. Okay, well, we already know this is supposed to be 75 too. Let's just double check. Maybe we made a mistake. 10 times 10 is 100. Minus 25. Boom, 75. All right, cool. Now we got those little things, but they're asking for the measure of the angle ABC. ABC is the big one. 75 plus 75 is 100. So the measure of angle 150. I was just kidding. ABC is 150 degrees. Yay. All right, so that is our final answer. And I do like it when it's circled or boxed in, so it's like clear to see, easy for me to read. All right, I hope you guys have an awesome evening, and I will see you tomorrow. I'm so sorry. I'm going to bring in something good for you. Bring in some treats, okay? I'll make it up. All right, you have a good night. Don't forget to submit your homework by 11:59 p.m. Bye! There it is, assignment number 5, page 20 to 30, and it looks like a lot, but just like, let's calm down a second here. So it's 3 to 14, all of them, 21 to 27, just those little bits, 29 to 31, and 40 to 42. All right, you know the deal. You have any questions about it, you can hold it. Don't, try your very best. Work amongst yourselves. I know you guys are all smart in here. You'll be fine. And then, like I said, I'll see you tomorrow.